Are you tired of having to light your own candles? Do you have trouble figuring out how candles work? Or maybe you're tired of burning your hair on accident? Well, do we have the product for you? The candle lighting plasma robot arm is the perfect tool to keep your hands free when you need that candle lit. Featuring slick and innovative technology, this robot arm has all the gizmos and gadgets you need to bring some ambience into your home. This bold piece of equipment will look great in any household. All you need is two 200-volt, 6-amp batteries, this very specific candle from IKEA with a radius of 3.8 centimeters, a laptop, and possibly some lighter fluid. How does such a marvelous piece of equipment work? Let's find out.
Hello. My name's Anahid. This is me and Tim's project. It is a robot arm that uses plasma to light candles. We will begin with a demonstration. So we use the serial monitor to control the arm that creates the plasma. It's completely an automated process, so the plasma arm uses sensors to figure out where the candle is located, how tall the candle is, and then it moves the end of its arm to the candle wick, and it attempts to light the candle and shifts around a little bit until it finally lights the candle. So first off, our arm uses an ultrasonic sensor which scans. It goes around this way 180 degrees, and then it goes back 180 degrees, and it records the readings from the ultrasonic sensor to sense if there's an object in its periphery. And then it takes the average measurement of the middle of that object, and then moves to the middle of that object, raises itself up in order to figure out where the top of this object is, and then stops at that height. And then it repositions itself to move both of its arms such that the plasma at the end of the arm reaches the object, or the candle wick, and then it deploys itself down after recording what the height of the object was. The arc generator is located at the end of the arm, is where you go. So the way that our plasma arm works is that there's an arc generator situated on the end of the arm right here, and it sets up 6 volts to 7 kilovolts at the ends, which causes a dielectric breakdown of the air. And so electrons are free to travel between the 2 exposed wires right here. And they travel the closest distance between each other to kind of propagate sometimes. So what it does is it turns on the arc generator once, tries to light the candle, checks whether there's a flame with the flame sensor, and if there is, then it stops the machine. If there's not, it lights the plasma again, and then it continues to do that several times until there's still no flame, and then it shifts slightly and repeats that process until there is a flame.
Hi, my name's Timothy, and I want to show you the Arduino setup we have going on here. So we had to plug in the motor shield in order to access both the stepper motor and the servo motor, but we didn't want to use all the pins, or we didn't want all the pins supplying the motor shield. So what we had to do is we had to have this kind of janky setup here in order to get the pins, in order to not use every single pin for the motor shield and use them for other operations. We also have this laid out in such a way that the breadboard can be easily accessed, and so that therefore each pin can also be easily accessed. We also have these relays which are used to operate the linear actuator, these two here, and then this one operates the arc generator. This is so that when we're running high voltages or high currents, they're not directly connected to our own Arduino, and therefore might mess it up. Our power supplies, the linear actuator requires 12 volts, and usually about 1 amp or so. And then the motors, and specifically the stepper, require 5 volts with a separate current than the Arduino can supply. We had lots of problems having the Arduino supply enough current, so we had to delegate some things to this as well. And then we had to have a separate power supply for the arc generator itself, because in the past we were having lots of problems with the arc generator actually messing with our circuitry, and so it would cause restarts and things like that. And so one way to fix that is to have a separate power supply, so you're on a separate ground and the arc generator isn't messing with that so much, but there was still sometimes the electromagnetic fields that would affect that. It was just that powerful. Some of the functions that we use, for instance, is the function that finds the center of the candle, or the angle that it is relative to the servo. And so what it does is it scans across and takes the angles that have a distance from the ultrasonic sensor that have a small distance. And so those angles get averaged to find the center. But because we have a little bit of stickiness here, as you can see, it's kind of dithering back and forth a little bit, we go from both sides in order to eliminate some of that error. And then the height is calculated by doing something similar with the ultrasonic sensor, where it will go to the center of the candle and then scan upwards until it sees the correct height, or it doesn't see anything in front of it anymore. Another function that's fairly useful is, in order to have a variable radius, we had to calculate, so if we know the radius and the angle from the servo, we can calculate using some trigonometry to move these arms in such a way that all you have to do is input the lengths of these arms and the angle and your radius, and then it'll just calculate for us where this is. So some of the problems that we ran into along the way to get it to the state that it is in now, one of the big problems was the wiring. For some reason, when everything was working nice on the Arduino and the breadboard, we would plug it into the ribbon cable into our actual robot arm, and then things would just not be working. Voltages we would be testing out, they'd be read wrong, and so we had to account for this a lot. And in one case, the arc generator seemed to have a big problem with this, and so we actually had to separate the arc generator's power from separate it from the ribbon cable in order to get it to work properly.
We basically couldn't extend the wires on any side of the arc generator because it would ruin the effect.
Then we also had a lot of problems with the stepper too. The stepper, until we switched to the smaller stepper that you saw on the robot arm, it really just was not very accurate, and it was causing a lot of weight on the servo as well, making it even more inaccurate.
So we had to switch out our stepper motor that was on the elbow of the arm for a lighter one. So we had to kind of change the entire half of the design of our arm for a lighter stepper.
Last minute too.
Last minute. And then of course the safety measures to make it pretty impossible to light live targets on fire, like moving students and small animals.
It's rough.